Good morning students, welcome back to online class. Today we are going to discuss the continuation of the book insight problems. See the fourth one. A 900 kilogram car moving at 10 meters second power minus 1 takes a turn around a circle with a radius of 25 meter. Determine the acceleration and the net force acting upon the car. Already we discussed the object makes in a circular path. It gives us an acceleration is called as the centripetal acceleration, isn't it? So using the centripetal accelerations only we are going to find out the what is the acceleration value. So what is the weight of the car is given 900 kilogram and it is moves with a particular speed. The speed is given 10 meters second power minus 1 and it is makes in a circular path. The radius of the circular path is given with 25 meter. So first we are going to write what are the data are given. So first we have to write the mass of the car or weight of an object is given, that is 900 kilogram, and the velocity value is given v is equal to 10 meters second power minus 1. The radius of the circular path is given. The radius already you know it's denoted by the symbol is smallest r. R is equal to 25 meter. So first what we have to calculate? The acceleration. The acceleration is nothing but the centripetal acceleration. Already we know the formula. Centripetal acceleration is equal to v squared by r. V be the velocity or the speed of the car and r be the radius of the circular path. Now we got to substitute the values. So what are the values? V value is given 10. So 10 square is divided by, what is the r value? 25. So what will come for 10 square? 10 square is nothing but 10 into 10 is needed. So 10 tens are 100 is divided by 25. So what will come? 425 is 100 is needed. So the acceleration of the car is 4 meters second power minus 2. So using the acceleration of the car, we could able to find out what is the net force is acting on an object. So the net force formula already we know. According to the Newton's second law, we could able to find out the force formula. So F is equal to m into A. M be the mass of the car or the weight of the car and A be the centripetal accelerations. Now we want to substitute the values as m is equal to 900 and A is equal to 4. So what will come? 9 4s are 36 is needed. 36 00. What is the unit of force? Newton. So the 4 meters second power minus 2 amount of the acceleration is acting on the object. It gives us a force that is nothing but the centripetal force. Its value is 3600 Newton. I hope students you understand this problem. A equal to V squared by R. F is equal to MA. Okay, now let us move on to the exercise problems. Roman letter 8th one. The first problem. A ball is generally dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meters second power minus 2, with what velocity will it strike the ground? After what time will it strike the ground? So it is given for the motion of an object. It comes for the freely falling object is needed. So here let us consider the object is ball. The ball is dropped from the particular height. So what is the height? or it covers the distance is given, that is distance equal to 20 meter, and the velocity is increases uniformly, isn't it? When the object is comes towards the downward direction, the velocity is increases. Here the rate of 10 meter second per minus 2 is given. What value is given? The rate of velocity is nothing but what? Acceleration, isn't it? So the ball, it moves with a particular acceleration and afterwards it strikes the ground. So which velocity the object is reaches? We don't know that one, isn't it? So first we have to find out what is the velocity of the ball when it is strikes the ground. And next we got to find out what is the time taken of the ball when it is strikes the ground. We are going to find out. So first we have to write what are the data are given. First what is given? The distance is given. Distance is nothing but is a particular height of the building. Let us consider the ball is dropped from the particular building. So the distance value is given. Already we know the distance symbol is S equal to 20 meter. And after that what happens? The ball will be accelerated, isn't it? So the acceleration, it is denoted by the symbol is A. A is equal to what value is given? 10 meter second power minus 2. And after that, the ball is started from the particular height from the building only. So there is no initial velocity, isn't it? Already we discussed in the previous video also. So initial velocity, it is denoted by the symbol U is equal to 0 only. So what are the values we are going to find out? That is the final velocity. What is the symbol for the final velocity? It is denoted by the symbol is V. We have to find out. And what is the time taken to reaches the ground is that is T. Then values is also we are going to find out. Using the equations of motions only, we are going to find out the final velocity and the time taken of the ball. We are going to find out. Already we know that. What formula? We have to using the third equations of motion. What is the formula? V square is equal to U square plus 2AS, isn't it? Because in this problem the acceleration and the distance values are given and it's understood the initial velocity will be 0 only. So using these three values we could able to find out the final velocity. Now you got to substitute the values. V square is equal to U value is 0 plus 2 into what is the value of A? A value is 10 and what is the value of S? S value is 20. So what will come? That is 0 plus 2 tens are 20, isn't it? 20 20s are what will come? 400, isn't it? So 0 plus 400 is equal to what? 400 only. So V square is equal to 400. We have to find out what is the value of the V only. So take a square root on both sides. So the square will be cancelled out, isn't it? So V is equal to root of 400. What's the value of root of 400? It's nothing but 20, isn't it? 20 20s are 400 only. So V is equal to 20. What's the unit? Meter second power minus 1. So the ball, it moves with a velocity 20 meter second power minus 1. It strikes the ground. So we find out the velocity value. And afterwards what we have to find out? What is the time taken? Isn't it? So here also we have to using the equations of motions only. So we know that the first equations, V is equal to what formula? U plus AT. Because the V already we know and A also already given the problem, isn't it? So using this formula, V is equal to U plus AT and substitute the values. What are the values are known? V value already we calculated 20 is equal to U value is 0, isn't it? Plus A. What's the value of A? A value is given 10 into T. Isn't it? So what will come? 20 is equal to 10 into T is equal to what value? 10T, isn't it? We have to find out the T value. So 20, the 10 is cross multiplied, it gives 20 by 10. So 1 10 is 10, 2 10s are 20. So what is the time taken? T is equal to 2 seconds. So after the 2 seconds, the ball will strike on the ground. This is the problem. Are you understand, ma? So what are the formulas we are using? V square is equal to U square plus 2AS and one more formula we have to use. V is equal to U plus AT. I hope students you understand the problem. Let us continue the next problem. Second one. A racing car has a uniform acceleration of 4 meters second power minus 2. What distance it covers in 10 seconds after the start? So here it is given what? A race car is given. The race car is its accelerator, and it is a particular acceleration value is given 4 meters second power minus 2. We have to find out after the 10 seconds, we have to find out the how much distance covered by the racing car. So first we have to write what are the data are given. So what data is given? First the acceleration value is given. So what is the symbol of acceleration? A. A is equal to 4 meters second power minus 2. And next what value is given? Time value is given. A time, a t is equal to 10 seconds. So what about the initial velocity? In the starting point there is no velocity is needed. So the initial velocity, what's the symbol of initial velocity? Smallest u. U is equal to 0. So we have to find out the what is the distance covered by the racing car. That is yes only we have to calculate. Okay. So we have to use the equations of motion. Already we know that the second equation s equal to ut plus half into at square. This formula only we are going to use. So s equal to ut plus half at square. Now we got to substitute the known values as u value is 0 and t is 10 seconds plus half into a. What's the value of a? 4 into t square. The t value is given what? 10 square. Isn't it? The 0 is multiplied by any number. It gives the value 0 only. So 0 plus half into 4 into 10 square. 10 square is nothing but 10 tens is needed. What is the value of 10 tens? 10 tens are 100. Now we have to simplify. So what will come? 1 2 is 2, 2 2s are 4. So 2 is multiplied with 100. It gives the value is equal to 200. This is the distance covered by the racing car. S equal to 200 meter. Are you understood, children? So what formula we are using? S equal to ut plus half at square. And substitute the known values and simplify, we will get the answer. Thank you, children.
Good morning, my dear students. Welcome to the chemistry online class. Today we learn about electronic configuration of atoms. What is electronic configuration? The electron configuration of an atom is a shortened method of writing the location of electrons in the atom. We know electrons revolving around the nucleus in an atom. So, electron configuration of an atom is a shortened method of writing the location of electrons in the atom. This distribution of electrons is governed by certain rules or conditions known as Bohr and Bury rules of electronic configuration. How to write the electronic configuration of atoms? We follow 3 rules. First rule: the maximum number of electrons that can be accommodated in a shell is equal to 2n square, where n is the serial number of the shell from the nucleus. So, what is the first rule? The maximum number of electrons that can be accommodated in a shell is equal to 2n square. This is the first rule. So, in the first rule, the formula 2n square. N means number of shell. So, we know k is the first shell. So, k is equal to 1. Number is equal to 1 because k is the first shell. So, n is equal to 1. So, instead of n, we substitute 1. So, 2 into 1 square is equal to 2. That means k shell, maximum it having 2 electrons. And next shell is L shell. That is a second shell. So, instead of n, we substitute 2. So, 2 into 2 square is equal to 2 into 4 is equal to 8. That means second shell, L shell having maximum 8 electrons. like M shell having maximum 18 electrons and N shell having maximum 32 electrons. So this is rule 1. Maximum number of electrons is equal to 2n square. So next, rule 2. Shells are filled in a stepwise manner in the increasing order of energy. That means first electrons filled in a first shell, that is K shell. Once K shell filled means electrons will go to the next shell, that is L shell, like that. Once L shell completed means next it go to the M shell. After completion of the M shell, it go to the N shell, like that. So second rule, shells are filled in a stepwise manner in the increasing order of energy. Next, the last rule, rule 3. According to octet rule, the outermost shell of an atom cannot have more than 8 electrons. So, according to octet rule, the outermost orbit, that means the last orbit, cannot have more than 8 electrons. We see one example. See, this is the electronic configuration diagram of calcium. We know atomic number of calcium is 20 and atomic mass of calcium is 40. Atomic number 20, that means 20 electrons are present in calcium. So how many electrons are present in calcium? 20, because number of electron is equal to atomic number. So we have to write the electronic configuration is 2, 8, 8, 2. We can't write 2, 8, 10. But we know in the first shell maximum 2 electron present, second shell maximum 8 electrons present. In the third shell maximum 18 electron present. Then why we not write 2, 8, 10? Because based on the third rule, the outermost shell of an atom cannot have more than 8 electron. If you are writing 2, 8, 10 means the outermost shell having 10 electron. But according to the octet rule, we cannot write the outermost orbit 8 electrons. So 2, 8, 10, that is wrong. 2, 8, 8, 2. This is the correct way to write the electronic configuration of calcium. Next, what is the electronic configuration of aluminium? You know the symbol of aluminium is Al. Atomic number of aluminium is 13. That means 13 electrons are present in aluminium. So, total number of electrons present in aluminium 13. Then how we write the electronic configuration? Totally 13 electrons are present. So, in the first shell, 2 electrons maximum present. In the second shell, 8 electrons maximum present. So 2 plus 8, 10. So remaining 3 electrons only here. So that 3 electrons, because L shell completely filled. So next that remaining 3 electrons will go to the M shell. So 2, 8, 3. This is the electronic configuration of aluminium. So 2 plus 8 plus 3 is equal to 13. That is the atomic number. That means total number of electrons. Okay students, I hope you understood how to write the electronic configuration of atoms. We follow 3 rules. First rule, maximum number of electrons that can be accommodated in a shell is equal to 2n square. In the second rule, shells are filled in a stepwise manner in the increasing order of energy. And the third rule, according to octet rule, the outermost shell of an atom cannot have more than 8 electrons. So next we learn about valence electrons. What is valence electron? Number of electrons present in the outermost orbit or energy level is called valence electron. That means in the last orbit, how many electrons are present? You count, that is the valence electron. Look this example. This is the structure of silicon. How many electrons are present in the outermost orbit? That means the last orbit. 1, 2, 3, 4. So valence electrons is 4. We see another one example. Okay, next example. In chlorine atom, how many valence electrons are present? What is mean by valence electron? Number of electrons present in the outermost orbit. And children, you count 1, 2, 3, 4, 5, 6, 7. So there are 7 electrons present in the outermost orbit. So valence electron is equal to 7. So students, what is valence electrons? Valence electron means the number of electrons present in the outermost orbit or shell is called valence electron. Okay students, I hope you understood this class. In the next class, we will learn about valency of atom. Thank you.